If we've got a fairly large network with lots of switches and lots of VLANs and lots of trunks interconnecting those switches, it starts to be an administrative burden to keep track of all the VLANs and all the switches and making sure that everybody agrees. Well, Cisco has good news for us. We can use something Cisco calls the VLAN Trunking Protocol, or VTP. Don't be thrown off by the name. I know it says VLAN Trunking Protocol. It's not really a trunking protocol, I would say. It's not like .1Q. It's not going to tag frames as belonging to a specific VLAN, but it does flow over a trunk. It's a protocol that flows over a trunk, and it carries VLAN information. So we call it the VLAN Trunking Protocol, or just VTP for short. But what VTP can do for us, and what we'll be discussing in this lesson, is we can create a VLAN on one switch, and that information can be propagated over a trunk to our neighboring switch. And that neighboring switch can say, I just received an advertisement about a brand new VLAN. I'm going to add that to my VLAN database, and I'm going to tell my neighbors about it as well. That way, I get to create a VLAN on just one switch and have that change propagated throughout all of my switches. If I want to do that, we can certainly set some limitations on that, but we can ease our administrative burden using VTP. Let's start discussing VTP in a bit more detail. Now that we understand about VLANs and trunks, let's imagine that we had a switched topology that looks like this. We've got 7 switches. These switches are interconnected with trunks. We'll say that they're IEEE 802.1q trunks, but they could be ISL trunks. And we want to add a new VLAN. Let's imagine that a new department has been created within this building. We want to create a new VLAN for that department. How would we do that? One option is we could go to the first switch and say, you have a new VLAN. You have VLAN 300, and then we would go to the next switch and we would say, let's create on you a new VLAN of 300, and we would go to the next switch and the next and the next and the next and so on. That's a lot of work. That doesn't scale very well to have to administratively add a VLAN on every single switch. Fortunately, if we do have a topology like this, we could take advantage of something called VTP, the VLAN Trunking Protocol. Don't be thrown off by the name. The VLAN Trunking Protocol, the name sounds like it should be a trunking protocol, a protocol that does trunking. It's really not. If I could name that protocol, I would call it the VLAN Advertisement Protocol, not the trunking protocol, because that's what it does. It advertises VLANs. Let's go back to our scenario where we want to create VLAN 300 on all of these switches. What we could do with VTP is we could create VLAN 300 on this top switch, and then we could send VTP advertisements out over trunk links. That's the way VTP works. It sends VTP advertisements over trunk links, only trunk links. And the next switches, when they see that advertisement, they could say, we now also know about VLAN 300. You see, we're automatically updating the VLAN databases in all of these switches. And the switches that receive the VTP updates, and they add VLAN 300 to their database, they could then forward those VTP advertisements on to the switches beyond them. Suddenly, everybody in the topology knows about VLAN 300. It's added to everyone's database. And there are several VTP options that we can set when we're configuring VTP. First of all, in our topology, do we want to be able to go to any switch and add or delete or modify VLAN and have that change propagated to all the other switches? Maybe not. What we could do is go to one switch and say, you're operating in client mode. If we have a client mode switch, it will receive VTP advertisements. It will update its local database to reflect this newly learned information. It will still forward VTP advertisements. What we cannot do on a client is connect to that client and administratively add, delete, or modify VLAN. The way that client's VLAN database is going to be updated is through VTP advertisements. Well, if that's a client, what's a server? A server is a device, such as the one we began with. It's a switch on which we can create, modify, or delete VLANs. Can we have more than one server in the topology? Yes, we can. We can have multiple servers, we can have multiple clients. There's one other option as well, and that other option is a transparent mode switch. let's say that this switch is operating in transparent mode. With transparent mode, yes, we can go to that switch and administratively add, create, or modify VLAN, but that change is only taking place on that switch's VLAN database. That transparent mode switch is not blocking VTP advertisements. If we receive a VTP advertisement in from a server into a transparent mode switch, no problem, it will forward it on. It's just not going to update its local database based on that advertisement. And before we get into the configuration, let's make a really clear definition of these three different modes of VTP. Here we have our three modes of VTP operation. We've got a server mode switch. On a server mode switch, we can administratively connect via the console, via telnet, via secure shell, and on that switch, we can create a brand new VLAN, we can delete an existing VLAN, we can modify an existing VLAN, and just because that we're able to make all these changes on a switch, the switch can still update its local database based on received advertisements. We can have more than one server in the network. If we receive a VTP message into a server switch, it can forward it out, remember only over trunk links, to other switches in the network, and this server, it can originate VTP advertisements. It can say, hey guys, here's my VTP database with all of its parameters. And the other switches that receive that advertisement, they can take a look at that advertisement and say, well, let me compare your database to my database. Let me determine which one is the most up-to-date. How do the switches determine which database is the most up-to-date? Well, every time a database change is made, every time we add a VLAN, delete a VLAN, modify a VLAN, every time a change is made, there is a number called the configuration revision number that's associated with the switch's VLAN database, and that number gets incremented every time we make a change. And if I'm a switch and I have a configuration revision number of 10 on my VLAN database, and I receive a VTP advertisement, and that VTP advertisement has a configuration revision number of 11, it's bigger than my number. Therefore, it must be newer. It must have an update that I don't know about, and I will update my VLAN database with the information that I just received. On a switch that's running in client mode, we cannot administratively create, delete, or modify VLANs. We will be updating our VLAN database based on received advertisements, and if we receive a VTP message, yes, we can forward it on over trunk links. And something that's really misunderstood about clients, a client can originate, we can source a VTP advertisement. Here's what I mean. Even though we're not able to make changes on that client, let's say that I've had that client in isolation. I've had it on my desk, I've been configuring it, I'm ready to add it to the network. When I add it to the network, that client, it's going to send out its VLAN database to its neighboring switches. We're trying to agree on who has the most up-to-date copy of the VLAN database. So even though we're not able to make a change on that client switch administratively, it will still advertise out to its neighboring switches, here's my VLAN database. Once all of the switches in the topology agree on a common VLAN database, they all have the same configuration revision number, then synchronization is complete. Next, let's consider a transparent mode switch. On a transparent mode switch, we can administratively create, delete, modify VLANs. However, those changes are only going to be reflected on the local VLAN database, just on that switch. We're not going to advertise out our VLAN database. In other words, we don't originate, we don't source any VTP advertisements. Now, we can forward VTP advertisements or messages that we receive out to neighboring switches, but just because we're forwarding on those messages doesn't mean we're paying attention to them. We are not going to update our database based on those received advertisements. And transparent mode can help us out in this way. If we don't want to run VTP on a switch, there's not a way to turn it off. You cannot say no VTP and turn it off. It's going to be running on your Cisco Catalyst switch. The closest thing you can get to turning off VTP is to make that switch run in transparent mode, because that switch is not going to be updating its database based on received advertisements. It's not going to be sourcing advertisements, but it's not going to block VTP messages that are flowing through the VTP domain. Let's go back to our topology now and walk through an example. Let's label these switches as servers or clients or operating in transparent mode. I'll say that the top switch is a server. We'll say we have another server. We've got a client. We've got a transparent mode switch, another transparent mode switch, and finally a server and a client. Right now, let's imagine that the configuration revision number, I'll just abbreviate that, the configuration revision number in this topology equals 10. I go to this top switch. It could have been any of these server switches, by the way, but I'm going to go to the top switch and I'm going to say let's create VLAN 300. As soon as I do that, my configuration revision number, I'll just abbreviate that, it goes from 10 to 11. Now that advertisement is going to be sent out over trunk links to the next switches. They're going to see this advertisement, and the server and the client specifically are going to say, is this configuration revision number of 11 greater than my configuration revision number of 10? Yes, it is. Based on that, I'm going to update my local VLAN database based on this advertisement. What is that update? That update is the creation of VLAN 300 on these two switches. Now, what about this transparent mode switch? This transparent mode switch, it sees the advertisement, but it ignores it. It's going to forward it out. It's not going to block it. It's going to send it down to this client switch, but it does not make an update. We do not create VLAN 300 on the transparent mode switch because of that advertisement. Well, let's say that each of these switches, they do forward that advertisement downstream to their neighboring switches. Again, the transparent mode switch, it does not make an update. It does not respond to those advertisements, but this server down at the bottom, even though it's a server, it can still respond to those VLAN updates. We're going to say you now have VLAN 300, and the client mode switch, it's also going to update its database because the configuration revision number on that advertisement was greater. It now also has a VLAN of 300. Once we have synchronized and all the clients and servers agree that this update has been made, we're going to go to a configuration revision number of 11. And that's going to be our steady state until another change is made. And when we made that change on this server up at the top, that change was sent out immediately. We didn't wait for some interval in order to send out the update. It happened immediately. However, be aware that VTP is going to send out a VTP message every 5 minutes. And this is not a VTP message containing full VLAN information. It's going to contain things like the VTP domain name, the configuration revision number, some other data, but it's not going to contain all the VLAN information. It's not going to put a big bandwidth impact on the network, in other words. And we'll take a look at the configuration of VTP in just a moment, but here are some things that have to be in place in order for VTP to work. The switches that are going to be exchanging VTP information, they need to belong to the same VTP domain. That's one of the configuration parameters we're going to give on a VTP switch. What domain do you belong to? This domain is case sensitive, by the way, and it needs to match on our neighboring switches for those switches to exchange VLAN information. VTP advertisements only go over trunk links. They're not going to go out of access ports. And we could optionally have passwords. The passwords need to match, and we might want to add a password for security purposes. I would also want you to know about the different VTP versions. There are currently 3 versions of VTP. We'll just call them V1, V2, and V3. We're primarily going to be using version 2. The big difference, in my opinion, between version 1 and version 2 is this. Let's say that we had a topology with more than one VTP domain. With version 1, if this transparent mode switch belonged to the domain of CCNA2 and the top switch belonged to a domain of CCNA1, 1, even though this is a transparent mode switch, it would not transparently forward that VTP advertisement out to the bottom switch because the domains didn't match. That's probably not a good thing. We probably want a transparent mode switch to always forward VTP advertisements. VTP version 2 will do that for us. We're not going to be concerned about VTP version 3 in our discussion. VTP version 3, it's supported on some of Cisco's newer higher-end Catalyst switches. It's not something we really need to be concerned about right now. It's got some additional support. For example, it's able to advertise extended VLANs. VLANs in the range of 1006 through 4094. It's going to be able to advertise something called a private VLAN. It is going to be backwards compatible with VTP version 1 and version 2, so that's good news. But primarily, we're going to be using VTP version 2. And one other feature I want to make you aware of before we go out and start doing the configuration, and that is VTP pruning. Let's imagine that on this top switch we have VLANs 100, 200, 300, but off of this bottom switch, just as one example, let's say that I've got a PC and this PC belongs to VLAN 100. Let's say that I have a network attached printer and that printer belongs to VLAN 200. I don't have any devices, I don't have any ports that are members of VLAN 300. But by default, a trunk is going to forward traffic for all VLANs across that trunk. And we could create a list of allowed VLANs over that trunk, but that's something that we administratively have to do. Wouldn't it be great if the switch could just determine that I don't have anybody belonging to VLAN 300, so to save bandwidth, don't send me any VLAN 300 traffic, just prune that VLAN off of this trunk. That's what VTP can do for us. If there is no VLAN 300 traffic needed over this trunk link, by turning on VTP pruning, we can dynamically prune off that unneeded VLAN of 300. That's the theory of VTP. Now let's go see how to set it up.